Hello, you're looking at an AurigaMAX Block 2.1 rocket on the pad, nearly fully fueled and ready to launch the second Optics 2 satellite. No hardware, range, or weather issues are being tracked at this time, and we are go for liftoff just over 5 minutes from now. As with the last Optics 2 mission, we are going for another attempt at landing our first stage booster on a ship, far downrange at sea. We got very close to landing last attempt, but we're just a little off target and experienced an engine failure. This booster, B1010, has undergone many upgrades, including a more advanced heat shield system, RCS control, and software updates. Starting this flight, and for the remainder of our experimental sea landing campaign, the booster will have a command sent to it after staging to initiate the descent to the ship, and will only be sent if everything is nominal. If anything is off, we will divert the booster just a little to the north of the ship for a soft splashdown. However, the goal for us, this time around, is to actually land successfully on the deck of landing Ship 1, and we believe we can do it. While a ship landing is our secondary mission, the primary mission today is to reach a 350-kilometer Earth orbit with the second stage and deploy the Optics 2 satellite. The Optics 2 satellite is part of the Geo-Optics satellite family, designed for Earth observation and advanced imaging. It is focused on environmental monitoring and atmospheric data collection. Optics 2 captures high-resolution images and data to assess climate change, pollution levels, and ecosystem health. It also supports disaster response efforts by monitoring areas affected by natural disasters like wildfires, hurricanes, and floods. Its purpose is to provide crucial insights into Earth's systems, enabling scientists to track environmental changes with improved accuracy. Yesterday, we revealed the render of what our AX-2R engine will look like. Here it is in case you missed it. The AX-2R is a new, vacuum-optimized staged combustion engine to be used on the Sagittarius upper stage. We collaborated with Nova X to design the engine, and the first development article will be delivered by next month. Let's take a look at today's mission profile. At T-0, the booster's engines ignite and the vehicle lifts off from the pad. 8 seconds later, the pitch-over program begins, which gives us the horizontal velocity needed to reach orbit. At 1 minute 5, max Q is passed, the point of maximum dynamic stress on the rocket. At around 2 minutes in, the first stage engines shut down in preparation for staging and Stage 2 ignition. Stage 2 flies under its own power for about 10 seconds before jettisoning the fairing, exposing the Optics satellite to space. 1 minute later, the final pull for booster recovery is completed and the command is sent. At 3 minutes 20 seconds, the second stage engine cuts off for its extended coast phase up to apogee. By the way, you can now see the strong back retracting. Then, at 4:08, the booster's entry burn starts, scrubbing off some initial velocity before the landing burn at 4:55. The landing burn continues for about 20 to 30 seconds before the booster should hopefully touch down softly on the deck of our ship. Stage 2 coasts until 1825 for the final circularization burn before payload deployment and mission success. You'll notice that we removed the partial boost back burn from last ship attempt, and that is because we want to push the limits of the booster to gain confidence in steeper profile recoveries.
Vehicles in auto idle. Vehicles in startup.
Auriga has cleared max Q and is approaching several events. Main engine cutoff, where all three engines on the booster will shut down, followed shortly by stage separation and upper stage engine ignition. After staging, the second stage's fairing will separate, exposing the optics to satellite to space. Meanwhile, the booster will be coasting up through space while performing a slow flip maneuver in preparation for atmospheric re-entry.
Main engine cutoff. Stage separation confirmed. Fairing separation confirmed.
Stage 2's fairing has been separated successfully, and the first stage is slowly flipping in preparation for entry using the RCS thrusters, the small white flashes you see. Should expect to hear some good news from Mission Control any second now.
Boosters go for landing, ship recovery bugs are true.
Alright, and you heard that there, we are go for booster landing. Meanwhile, the upper stage with the optics 2 payload is nearing the end of its burn, so let's watch as Seco 1 occurs.
Seco.
The second stage is now entering its roughly 20-minute coast phase. Let's focus on the booster as we bring it home. The next event is the entry burn, which will scrub off some extra velocity and bring us closer to the target landing site. After that, the booster will free fall for a little bit again before the landing burn, which takes us right to touchdown.
Stage 1 entry burn startup. Entry burn shut down.
Entry burn has wrapped up and you can really see the plasma building around the vehicle. I'll see you after an exciting landing attempt.
Stage 1 landing burn.
Stage 1 landing leg deployed.
Stage 1 has landed on the drone ship for the first time ever. Vehicle safing operations are well underway. Congratulations to all the teams. We are going to switch over to Stage 2 telemetry as it coasts through space up to apogee before the second burn and payload deployment. We are back from the coast phase, and are awaiting that circularization burn or CS2. Stage 2's second and final orbital burn is underway. Circularization burn completed, and we are in the target orbit. Now standing by for payload separation.
Optics 2S2 separation confirmed.
With the successful deployment, this brings our mission to an all-around success. Thank you for joining us for our first successful sea landing, and we'll see you next time.